let's just begin. So over the next 20 minutes or so, we'll be talking about farm fresh. Is it realistic expectation? What are the keys to freshness? And then Kyle is going to be talking about what is deep chill and what is the deep chill process for fish harvesting and processing. And then in the end, we're going to look at what's the impact on your operations and bottom line, because at the end of the day, businesses all care about that. So speaking about farm fish, we know that aquaculture, you have a lot of advantages over wild fisheries, simply because there are lots of greater control over many processes. You can choose whenever you want to harvest. You can choose how much you want to harvest based on the demand of the market. There are technologies that you can keep fish alive just until minutes before you start the processing. So that is great. There are also lots of quality control over the production of fish. And lots of farms now have the opportunity to select the location. So it's always about location, location, location. You want to be closer to the customer, as close as possible, because then you can deliver that promise of farm fresh. But then how long does this freshness going to last? That's a great question. So let's first define what is freshness. What are we looking at when we talk about fresh fish? When you go to the market, you're probably looking at the fish eyes. Are they bulging? Are they shiny? Or are they gray? How about the gills? Is it moist? Is it bright red? Does it look good? Does it look fresh? Looking at the skin, is it still moist and shiny? Is it dried out? You don't want to buy dried fish, right? Is it unharmed? Are there any freeze marks? Are there any like cuts and bruises on the skin? Nobody likes that. How about the body of the fish? Is it firm? When you press it, is it going to bounce back or is it going to stay there? So that's a good telling sign, right? And about what if you're buying fillets, right? You cannot have any of those indications. So it makes it a little more difficult. So you have to know how to pick a good fillet. Is it tight and firm? Are there any gappings? Are there holes in there? Are there slits there? So those are all the signs that can tell you if a fish is fresh or if not. But it's really just nature. Naturally, fish dies, and then after that, the decay starts. So you would be losing that freshness over hours and days. But our focus or our really value proposition is how we can maximize that time that you have as a fresh fish. And is it possible to maximize? So let's look at some of the key elements or key factors that impact that freshness. Here's a graph that tells you about the storage temperature and the relative rate of spoilage. As you can see here, the higher the storage temperature, the faster that fish can spoil. It's really a relationship, a direct relationship between the two of them. And why does it matter? Because if you look at the conventional storage temperature, what you see on the left side, around 1.5 degrees to up to 4 degrees is the legal and conventional storage temperatures. That's 34 Fahrenheit. And below 0 to -1.5 is a zone that we call deep chilling zone. The fish is not frozen yet, but it's also below 0 degrees, so below 32 Fahrenheit. Studies show that I just showed you the rate of spoilage, if you drop this temperature from 1.5 degrees throughout your storage time to -1.5. From 34 Fahrenheit to 29 Fahrenheit, you can cut the bacterial growth by half. What does that mean? The faster the bacteria is, you have that activity, the faster the fish is spoiling. So if you cut that rate to half, you can extend that shelf life by almost double. So storage temperature is a key factor here. Another key factor is the rapid cooling. The faster you can get the temperature of whenever you're harvesting the fish, can be 12, 14, 15, 20 degrees Celsius, depending on your fish. The faster you can get that below 0 degrees, the faster you can halt that enzyme activity. And the studies also show that whenever you are, you see here on the lower line is chilling codfish with Deepchill, and the red line is with flake ice or conventional type of ice. You see the difference here. I'm looking at 7 to 8 hours until it reaches 0 degrees, and then I have 1 and 1.5 hours to get there. So studies show that when you can rapidly cool fish, you can extend the start of rigor process. So it will delay that. The beginning of that rigor is delayed. And then the end of it is also delayed. And the rigor process becomes longer and easier on the fish muscles. It becomes less intense. So therefore, it's not impacting very much on the muscles tightness, and you won't see gapping as much. So rapid cooling is another key factor. Just summarizing here some of the factors here. Rapid cooling, as I mentioned, it's very important in terms of extending the rigor process and giving you a better quality fish. Storage at sub-zero temperature is a key factor here. Another factor, as we spoke, you don't want to see a dried out fish. Nobody likes that. So you have to find a way to lock that moisture in, and have ways to have design handling mechanisms where you don't physically damage the fish body. You don't want to have any freezer marks or freeze burns on the fish. You don't want to cause any cuts and bruising, right? So those are all the elements that we discussed. Now, Kyle is going to talk about Deepchill and how it's going to help get you to that maximizing freshness.
Thank you so much, Mina. And this is a question we get all the time because people often think that Deepchill is just water and ice, and can't they just make this slurry ice themselves? But it's something completely different. Every piece of ice you've ever used in your life has probably been formed on a surface, whether it's plate ice, flake ice, shell ice, tube ice. What we do is completely different here. So we form our crystals in suspension of water, and we don't allow the water to freeze on the heat exchanger. So what happens is you get these tiny, tiny pearl-like or sphere-like ice crystals, maybe 0.1 to 0.2 of a millimeter in diameter. And because of that size and uniform shape of our crystal, it has completely different properties, and it has a different coefficient of performance, which is just a funny way of saying it pulls heat out of product a heck of a lot faster than crushed ice does. So between 10 and 40%, it looks and feels a lot like a liquid. It flows, it can be pumped relatively easily. Between 40 and 70%, it has the consistency of soft ice cream, and 100% snow is 100% snow. And again, one of the reasons that we can pull heat out of product so much faster than refrigerated seawater or flake ice and seawater is because of the amount of energy that's packed into a pound of deep chill. So I don't like the units of measure of this, watts per square meter in Kelvin. I would have preferred BTUs. But if you compare chilled brine to even a 25% deep chill solution, you're seeing that deep chill has 5 times the cooling power, pound for pound. So we are able to reject heat out of product that much faster. And this is what we see when testing is done. So a lot of this testing is third-party testing. We did not have a hand in this whatsoever. So this is comparing RSW with deep chill, where this yellow line here is the fish put in RSW. This orange line is the temperature of the water, and it behaves the exact way you would expect. You dump this big chunk of mass into the refrigerated water, and the temperature of the water spikes. Then the chiller works like mad to try and pull that heat out of the product. And this delta, this difference between the temperature of the fish and the temperature of the water, contributes to the coefficient of performance. So that's one of that's the reason that it's pulling the heat out of the product. Whereas this blue line is that same fish put in deep chill, and this dark blue line is the temperature of deep chill. When we put that big chunk of mass into our slurry ice, the ice doesn't change temperature, it just melts part of the ice fraction, and we maintain the same temperature. And so due to the greater difference between these two temperatures, we're able to really pull the heat out. And at a 3-hour mark, we've brought this fish down to 0 degrees Celsius, whereas it's at about 40 degrees Fahrenheit or 4 degrees Celsius in RSW. So at the end of the day, we get your fish colder faster, so they stay fresher longer, and that's everything that we do here. And when we'll look at how we fit into the different parts of your operation, so where do we fit in terms of the farm to table or farm to grocer model? So on harvest, don't harvest into an ice and water solution or put them into flake ice. Put them in deep chill, crash the temperature right away, hold them at that very cold temperature during transportation, continue to hold them at that cold temperature during post-harvest processing. And we can integrate with a number of different storage medium. We're very flexible in terms of the tank that we can integrate with. We'll have more slides on that coming up. Here we are integrating with a spiral tank. And this sorting and storage area is pretty darn important. And a number of you have these large holding tanks where the fish sit for 1, 2, 3, 4, 6 hours. And one of the things that we can do is hold your fish at that -1 degree Celsius or that 30.2 degree Fahrenheit mark, and hold it there without getting any colder and without getting any warmer, to give you more time to work through your catch. And then obviously, as it goes through filleting, you should see some gains in yield, and you can also use a deep chill for packing. So we're going to touch on a number of different areas here. And as promised, this is showing a number of different applications or how we integrate with a number of different tanks. In the top left-hand corner, they put fish into these tanker trucks or ISO trucks and get moved a number of hours between the farm and the facility. And this is a great application because the tanker is pre-filled with deep chill. It then goes to the farm. The fish then go in the tanker truck. And after 2.5, 3 hours, when that truck comes back to the factory, the fish are already cold. So there doesn't need to be any of these huge spin chillers or any of this additional equipment inside the processing facility. And here we are hooking up to a Helix tank. And over here, we can see these large holding tanks being filled with deep chill. I believe these are 50,000 pound tanks. And over here, we see some fish in deep chill, just in a tote. And in all of these instances, we're able to crash the temperature down to those sub-zero ranges. And if you were to look at fish inside an aquarium filled with deep chill, this is what you would see from a side profile. The fish would be all throughout the tote or tank, and the deep chill ice crystals would go through all the nooks and crannies, and it stays relatively homogeneous. So we're able to pull that heat out of the fish. And during transportation is actually one of the pain points that we talk about a lot with our customer base. Many people have told us that the well boat that does the harvesting pulls that temperature down to somewhere between 2 and 4 degrees Celsius. Then it goes into their transportation method, could be a tote, could be a tanker. But by the time it gets to the processing facility, that fish has gone up 1, 2, 3 degrees Celsius. And that makes a big impact in terms of quality and shelf life. So if you just ship in deep chill, we're able to continue to crash that temperature and hold it in that sub-zero range so that we maintain the cold chain all of the way to the processing facility. And if you're comparing us to a flake ice water solution, there are many instances where we're able to pack more fish into the same container because we reduce the fraction of ice or reduce the fraction of water to fish ratio. And here we are at the processing plant. So there's one experience that has stuck with me for a long time. And I was at a facility and I was speaking with the VP of operations who was giving us a tour. And he was talking about how much ice they put in the container. So in this 1,000-pound tote of fish, he was saying they chuck in about 150 pounds of ice to maintain the temperature. When him and I were watching the people shovel ice in, I turned to him and I said, that doesn't look like 150 pounds of ice. And he turns to me and he's like, yeah, that doesn't look like 150 pounds of ice. And what we're trying to get at here is if you have these manual processes where people shovel ice into a container or blow ice into a tank, it's not as accurate and it's not as consistent as we may have been led to believe. Whereas with a deep chill, a pre-metered amount of a very specific fraction can go into a container and give you consistency and automation in your operation. And here again, we see essentially the same thing. So deep chill is providing a buffer here. So instead of these fish rising 1 or 2 degrees through the processing center, instead they go into a tote of deep chill and we maintain that temperature to keep the fish colder faster. And this is a salmon application where they're in the tote and it's something very similar. So this is after they've been gutted and we're trying to maintain and maximize the freshness of these post-rigor fish. And one of the interesting things about rigor mortis is if you chill those fish down below 0 degrees Celsius, but above -1.5 degrees Celsius, the contractions become much less strong. And so you experience less gaping or gapping in the meat, and you end up with a firmer fillet that looks more desirable to the consumer. And this all has to do with rigor. And again, colder fish going through the filleting process have relatively higher yields. This is demonstrated by all of the large filleting machine manufacturers. So at the end of the day, cold fish, better quality fillets. But just as an overview here, the operational advantages. And again, the one overarching idea for us is this idea of flexibility, one system to support your entire cold chain. We can integrate with any of these different containers. Doesn't matter if it's a spin chiller or a large RSW style holding tank or a box or anything in between. That's something we've done before. Automation and reduction of labor costs. I think we've all thought about that small army of people at our facilities whose sole existence in life is to move and handle ice, as well as streamline and speed up the icing process. In that previous example where the people were shoveling ice into the tote, that could have been replaced by an automated pipe or just one person with a hose pouring deep chill over the fish. And this buffer storage to manage the bottlenecks in your operation. And that is a very key figure here, because that is where a lot of your waste and a lot of your downgrades come from. When the fish sit in those totes where the ice isn't keeping the fish at the bottom of the tote cold. And by the time they actually get processed, it's not #1 salmon anymore, it's #2 salmon. So this all feeds into the ROI equation, because we always say if our systems aren't making you money, or if the capital project isn't having a return, then it's not a capital project worth doing. So one of the ways we help is by increasing the production yield a number of different ways, from filleting to reduction of loss, reduce labor costs in many different areas of your operation, and eliminate this product degradation. So that is all what contributes into this ROI. And we just have some quick examples here. So if you harvest 250,000 pounds at a time, and the wholesale value of number one salmon is $3.25 a pound, and the wholesale value of number two salmon is $2.60 a pound, the cost of that degrade due to poor temperature control is over $100,000. And in addition, we have another example here where you're doing a same harvest size, 250,000 pounds. You're achieving about 70% filleting yield, and the value of those fillets is about $4.50 a pound. We may be able to give you somewhere between 1,500 to 3,000 additional pounds from the same harvest, which would be an additional $8,000 per harvest. And you can quickly see that it doesn't take a whole heck of a lot of harvests to achieve a positive return on an investment. No, that's it. I aim to have short presentations and long conversations. So that's it.
Thank you so much, Kyle. Okay.